Okay, so welcome and a very good morning to all. This is Prabha Singh from the IoT Academy. Last week, there was a very unstable network issue due to which I was not audible. So I would like to have a quick recap. I welcome all the participants to a very vibrant session on 5G 60, organized by the IoT Academy and Upskill Campus in collaboration with Ian ICT Academy, IIT Guwahati, other academic and industrial partners. The academic partners are ABES Engineering College, Indraprastha Engineering College, JP Institute of Information and Technology, Merit Institute of Engineering and Technology, Noida Institute of Engineering and Technology, St. Vincent Pallotti College of Engineering and Technology, and Sushant University, formerly known as Ansal University. 5G is the technology that is going to change the world we had not imagined earlier. There are very clear mandates from our Honorable Prime Minister, Shri Narendra Modi ji, from various events, and the most recent one, India Mobile Congress, IMC 2023. Shri Narendra Modi ji, in his inaugural address, highlighted India's tech achievements and aspirations, including the fast adoption of 5G in the country. He noted that the future is no longer a decade or a century away, but due to the advances in the technology, the future is here and now. Now, I would like to invite Kaushalendra Singh Sisodia, Chief Mentor of the IoT Academy. One second, sorry, now I would like to invite Kaushalendra sir, Chief Mentor of the IoT Academy, to give a quick brief on today's topic before we begin the session with our today's speaker. Over to you, Kaushal sir.
Okay, good morning, everyone. Thank you, Prabha ma'am. Dear friends, I remember the days during 2002 to 2003, since I have been working in telecom domain since it was in very infancy state. So during 2002 and 2003, many companies had backed out from 3G development, citing that it is too complex and impossible to achieve what is promised. So this is the days when 3G was like introduced, people were developing it, but it had too much promises, and people were who were making it, they were backing out because of the complexity. Similar is the case with 5G. We need to keep patience and keep contributing to make it highly successful. 5G is going to provide a seamless connectivity. This we have to understand very carefully, that what kind of features and flexibility it is going to provide to all the users, all the industries. So it is going to provide seamless connectivity whether we are indoor or outdoor. Using its heterogeneous network, it would provide highly scalable data rate as per users need, using its multiple antennas configuration. It would diminish the gap between how the people and things are connected to the internet. So far we were using internet of people, and the another silos was internet of things. These two silos would be diminishing, and they would be coming on the same platform using 5G. So 5G is quite ambitious. It is revolution instead of evolution. Let's listen to our speaker about his thoughts for 5G, a connected world. So we have a very eminent speaker today. Let's speak. Let's listen to him. Thank you, everyone. I would hand over to the next speaker. Back to you, Prabha ma'am. Thank you, everyone. Yes,
Hello.
ma'am.
Yes, sir. Thank you very much, Kaushal sir. Okay, so we have a very industry experienced speaker, Mr. B. Vasudev, Managing Director of FITEC India. FITEC has its headquarters in Germany that is into design and manufacturing of semiconductor modules. These modules are used in all kinds of applications. Example, home appliances, aviation, logistics, drones, electric vehicles, and many other domains, which includes telecom like 5G and 6G. So let us now welcome and listen to Mr. B. Vasudev about today's topic, 5G, a connected world. Over to you, Vasudev, sir.
Good morning, all. I know this is a Sunday time, and then so since I joined from home, so there were some technical glitches. Sorry for that. Okay, without wasting time, so let's jump into the session. Okay, so the 5G, the connected world. So what I will try to do is basically share my experience. Of around 20 years in the embedded field, and then how the existing uh, systems in different domains or verticals are going to change or shift with respect to 5G when it is coming to the 5G technology, and how these um, all things made up together bringing a new definition of connected world. So yeah, there might be some questions. Already all of us are connected through internet calls, through like say the today the we can reach to any part of the world through air, right? Like, so now what is the new definition of this connected world is what try to explore a little bit today with and aligned with some of our experience in the industry, right? Okay, so to quickly start, I believe uh, a small introduction of Phytech has been already done. So essentially we are a hardware manufacturers, and the good thing is basically, so we are 37 years already in the market, and then these are kind of some subsidiaries. So Germany is our main head office, and then like we have in US, France, India, and China. So globally we are 500 people. So Phytech India, I started in 2012 with a small team of 5 people, which was my startup. Today we are happy to say that like in last 11 years we could able to scale to 105 people. Uh, and most of them do develop these embedded systems in IoT and AI and the hardware part basically. So essentially we are hardware guys, but at the same time hardware would not run with the system software. So that's how we do the system software side. So a small glimpse of our German manufacturing unit. So we have 7 SMT lines in the basement of here. Like this is the manufacturing unit and this is the development unit. So 7 SMT lines manufacturing, and then like this is where we do whole of the manufacturing test automation in the second floor, and the third floor is specifically meant for the customer projects. And then we do all design and development beside of our manufacturing. So this is our manufacturing part. So we inaugurated this new building 2 months back. You can see the position of India right now in Europe and US. So currently the Indian talent is in high demand globally. And then, after COVID, the essence and then the growth of semiconductor companies, IT, AI, and all basically, right? So these are some numbers. Since last 37 years, we have been able to support more than somewhere around 12,000 customers to build their products. So we can proudly say today we are in 12,000 products globally inside. So like when you buy a laptop, Intel inside. So we can say you go to any industrial, transportation, medical. So we can proudly say we would be inside somewhere Phytech as a Phytech module basically. So we ourselves has developed more than around 6,000 projects basically, and then like these were the manufactured products, right? Like say what we do. So we do these system on module, single board computer, which is essentially the motherboard, embedded motherboard for all your AI and stuff, and then like how these are changing the world with respect to 5G. Let's connect those dots. right? And the Internet of Things, the low power sensor devices. We have a very high-end embedded imaging cameras for the industrial things. So AI, essentially today the AI, the first level of data uh, we are doing with image processing, right? Like, so there where we have a dedicated embedded imaging vertical in Phytech. And last but not the least, these all hardware do not works with software, without software. So we develop a Linux and Android BSP for these all hardwares basically. So let me quickly give my personal journey, so that like I believe a lot of us are merely all of us are technical, and maybe like a couple of guys are from business side or the but like I would like to share my technical journey, right? Like say 1993. Why I write 1993 is basically, so I started my software coding in 5th standard. So there where like my first programming started, right? And then like in 2010 I was done with couple of softwares, and then like 2020 I started teaching software, how to develop the software in C++, Java, VB, Oracle, and all those stuffs. And then 2005 is when I started my first embedded job, right? So so 2005 when I started exploring to learn Linux basically. So this was the Linksys routers available in the market, and one of my we used to stay as a bachelor. So one of the router in our room, I said like, hey guys, I want to buy it for half the price. So even though it was 3,000 rupees, I paid my roommates 1,500, and then like they bought the new one, and I got the older one for 1,500 rupees. So this was my first toy to learn the Linux. And then at that time I decided to develop something which would be in the same range of 3,000 rupees, and then like should be available to the developers around the globe to learn Linux. So whatnot, like bootloader, kernel, root file system, xyz. So there were 2009 with along with one of the partner in Bangalore. Somehow we were able to bring up with this computer, single boot computer, which was 2700. We really reached the target. But like it couldn't run for more than 2 years. So as a startup stories, a lot of startup stories. I was more contributing on the technical side. The product manufacturing and all were done by the partners. So somehow 2010 12 when I started Phytech India by merging my startup to this German company. So there were like after all the German learning, and then like the expertise of German and the quality, so we are proud to launch these first Swadeshi single boot computer, 100% designed, developed, manufactured in HSR layout, Bangalore. So this was one of our key achievement. But COVID came, so it got a little bit more slow. Now we have three variants of rugged boards with A5D2 IMX6UL, and then with TI processor and RISC-V. So we will see how RISC-V is contributing to the next gen 5G systems. So this is a small story about my technical journey, so that like and how these all things are connected with today's talk is basically the IoT journey. So I would try to share the product development experiences and IoT applications connected to 5G. Okay, so essentially let's now we are already done with 25 minutes. Then let's manage the time. Something like what I would do is we talk about typically four stories. Um, to really utilize this limited time. So what I would like to discuss with you guys is basically, let's take four high level stories from the industry. One from industry 4.0 or industrial automation, and the second one could be the most happening area, which is uh, transportation or EVs, or like automotive basically. So essentially we call it as a transportation vertical, industrial vertical, automation, transportation vertical. Third one, we will say that like the biggest change would happen in humans life, the contribution is the medical, right? So as we always see, good food, good education, good health basically would lead our new future, right, with innovations. So medical, so we third story we will discuss on the medical side, and the fourth story we will try to explore some smart agricultural stuff, so that how these 5G technology would contribute in this, right? Okay, so let's start with the little bit on, first of all, the evaluation. So how the way it has the cellular technology has evolved from 1G to 5G. A lot of in-deep technical discussions has been already happened last week, and then Kaushlendra sir has given a really detailed in-deep session. So I'm not trying to repeat them. So hopefully those that the last week session is available on the YouTube. Maybe like the hosting guys hosting team, can you share the YouTube link in the chat, so that like the people can save it for the next, maybe like later they can refer the 5G in deep. So what I do is carrying forward Kaushlen's 5G definition. Here we are more talking about the application, and then how the world is connected through these applications. So as rightly defined last week, saying that like, so till today the cellular communication was more known by the people, at least for by the common people. It is known only for voice calls, or for the internet, right? And then slowly the IoT things came, and now how these cellular technology, or how much percent of these cellular technologies are involved in this cellular communication is a kind of more than 50%, right? So now how these 50% of the contribution is done is, that's how like it is not internet of only like means the cellular communication is not only for the internet of people, but like now it is kind of like connecting the things together, and that's how it's coming to the connected world, right? So now let's define the things first, how from an electronics perspective, because tomorrow when you want to use a 5G technology, you need some devices. So these devices, let's see how we can categorize, right? So now the first class of devices, we call it as a system 1.0. So maybe a small example, I can take it as your wristband, right? Like, so now the 1,000 or 1,200 bucks, you get your a smart health device basically, which could be as small as like as much smaller than your watch also, I believe, right? Like, so what it does is it acts as a watch, but at the same time the essential sensors which has been embedded into this device is more on the your pulse oximeter, heart rate things, right? Basically, so it monitors your heart rate, and then by mean of which it also try to identify the number of steps you have taken a day, physically how much movement is in there in the body, right? Like, so what it does, it only sends the things and sends the data to your mobile device, right? So always your smart band is always paired with your mobile device, and the mobile device either can store the data locally, or again it transfer it to the cloud and do some analysis, right? So here if you see, this is a classic example of system 1.0 from a very user perspective, from an industrial perspective. If you see, a very small microcontroller which will be drawing some relays, which will be sensing some doors or like some sensors, like right. So any optical sensors for your object detection or kind of stuff. So there is a small sensors with some digital IOs or analog IOs. So these are the classic example of the system 1.0, which really sends the data and transmit it basically, or do some action locally. So these are essentially based on microcontrollers and very low power. It is very embedded. Earlier we used to code it in assembly, but today you can see that like those are coded in C, and then above C there are a lot of high level languages now has been developed even for microcontroller, right? So Arduino and all, like, so these guys are making one more wrapper on top of C, and then like giving you much more simple languages to code them. So what next? So the next was basically your apart from your specific task. Now you go with a more complex task, like you want to make a call, you want to check your emails, you want to have your scheduler reminders and whatnot. So basically, so it's like your smartphone, right? Like say whatever you could do in on your phone, smartphone or a laptop. So a couple of daily activities you want to do in your smartwatch. So you smart band to smartwatch you have switched basically, and then now here you can do a lot of applications. You can run a lot of applications. So these applications for essentially running these applications, now you have a need of operating system. So that's how you switch from a microcontroller to microprocessor, and you essentially need some operating system, either a Linux or an Android or a Windows. So some sort of operating system you need, and then you develop a lot of these applications, not getting into much deeper uh, technical development of the code. So for example, you want to store the data. Tomorrow you are not going to develop some database, write a database coding. So you use a ready available database software, and then you start storing your data. So that's how your system 2.0 has started basically. Now let's see the the next gen. So where we are now. So we all are very I would say fortunate, and then like we are lucky to have this generation with us basically. So where we could see a couple of these old generations, and then we are in the new era of these generations. So what this is basically, right? Like, so this is adding your artificial intelligence and machine learning to the devices, right? So edge computing, what you do call. But now the edge computing is limited for small activities, but like end of the day you want to push all the data and do a lot of analysis on the cloud, and you have tons of data. So there where like your next connectivity and communication technologies plays a major role. So you can see the third one. So we started with a health band to a smartwatch and to a AI watch, right? Like, so where you can do all your analytics on this device, and with a high speed communication to your cloud. So it can bring in a lot of new intelligence, and then on time intelligence on the device, and help you out. So this is a microprocessor plus a lot of hardware accelerators which come into the picture basically, right? So now let's try to connect these device computing to the 1G, 2G, 3G, 4G, and 5G. I do remember. So I started my IoT device things in 2005, when we used to do these energy meter, water meter, data collection, and we used to send it to the cloud using GPRS. So in the 2G, we used to get the GPRS modules. At that time, Wavecom and all were there. This is an era of 2005. I do remember when we used to interface them with the microcontroller using serial port, and then still I think the AT commands are still the same. So you can do some AD commands and then connect to the GPRS and start communicating the device. So that's how the 2G it started, right? Like, so now after that, like the 3G with some digital packetization, and then 4G more on the digital packetization, and then 5G. So now the 5G is bringing you the next technology. So essentially, from a layman definition, he is getting more speed, right? And for a technical guy, not getting more deep into that, you are getting a much reliable responsive connection, so which is the response time. So essentially, when you are looking from a communication technology, the data rate with the high speed, right, and the latency, low latency, these are the two factors which brings in a lot of different applications, right? So for example, in industrial automation, basically, right, the kind of shift happened from industry 1.0 to industry 4.0, right? So in industry 1.0, like where it was more your mechanical things, and then like the power from your hydropower or steam power, like the heat which used to generate some momentum, and then the devices are built, right? And then slowly then you started with energy shift from a natural resources to the electricity, right? Like, so now, so you started building electronic production machines, basically, so which is industry 2.0. And then slowly then you started for these electronic machines, now you started automation. So instead of a person sitting in front of a machine and then pressing start stop and then like doing the things, operating the machines manually, then you started connecting it to with a computer, feeding with a software, intelligent software, which will really do the same task what a person supposed to do. That's how you shifted to industry 3.0. And then finally connecting all these machines together, right? So you went from industry 3.0 to industry 4.0. Now here you can see that like in industry 4.0, it's already connected, right? Like, so you name some any wireless technology like cellular, you have these all till 4G or LTE. Basically now today you have a 5G, and in IoT space you have a lot of wireless technologies like Zigbee or Bluetooth or Wi-Fi or like LoRa or Sigfox, right? Like, so there are multiple technologies exists, basically, right? So now what is the next we are going to achieve with 5G? Okay, so how many of us have really heard about a digital twin? Digital twin, can you guys raise your hands? Digital twin. I'm waiting for better responses. Hopefully everyone is listening and awake. I know it's Sunday, it's a breakfast time. 11 isn't breakfast time, I know. So all of you guys are already awake. So you can grab your coffee, cup of coffee. Okay. Uh, and by the time all are awake, basically, or like all are back to the session, what I want is Where is the Zoom? Okay, here is the Zoom. Sorry. Okay, so at least we have 15 guys out of 130. Okay, so it's still increasing, right? Okay, no problem. So by the time couple of more things are there, I want to run a small video from our partners, semiconductor partners. So is the audio available for all of you guys? Someone can acknowledge?
I think so, audio is not available. It is not like we are not able to listen.
Okay, wait. Let me just check. So 22 guys have heard about digital twin. Maybe like a couple of you guys, if you have time, please post in chat what is your definition of this, and then maybe like let me just check quickly. Default share. Normally, I think it is with share. Advanced sharing option. Panelist. Yeah, I believe it should get.
Next revolution of intelligent, connected technologies is here. NXP has created a path to accelerate even greater breakthroughs. As machine learning continues to redefine what's possible through more flexible and robust software. The next revolution of intelligent, connected technologies is here. NXP has created a path to accelerate even greater breakthroughs as machine learning continues to redefine what's possible through more flexible and robust software platforms and rapid hardware innovations. This path to a more intelligent world starts with NXP's advancement of machine learning at the edge. Systems that empower devices with smarter decision-making, high performance, low power processing, and built-in security are critical to creating more intelligent and adaptive Internet of Things. As intelligence at the edge expands, so do the capabilities. Smart environments, industrial systems, and consumer devices become more efficient. Interactions become more seamless. Dangers, diseases, and potential failures can be detected sooner. NXP's EIQ machine learning software leverages huge advancements in AI and ML to to enable a world that truly learns and reacts to your needs. Whether it's a global transportation network, simultaneously monitoring millions of vehicles, drivers, and roadways to actively reduce their operating costs, smart security systems that recognize every family member, automatically adjusting to an individual's behaviors and help keep families safe whether they're home or away. Local governments actively monitoring public spaces and using real-time data to ensure their city remains safe and secure. Or automakers advancing the future of self-driving cars, automated driving functions through ADAS, and machine vision that recognizes, responds, and adapts to road conditions accurately and intelligently with a dedicated automotive-grade EIQ Auto. From voice control to face recognition, out-of-the-box intelligence of NXP Edge-ready solutions puts you on the fast track of design innovations. NXP is making machine learning at the edge more accessible. Together with our clients and partners, we can create smarter journeys, more secure systems, more intelligent environments, and truly exceptional user experiences by design. With our expansive Edgeverse computing platform, NXP is accelerating breakthroughs to advance our world. See what a more empowered edge looks like. Experience NXP's vision for machine learning at the edge.
Okay. So hopefully you enjoy this video, but maybe like let's come back a little bit to connect what it is. So now when we say digital twin, right? Like, so we stopped at digital twin. So now assume you are bringing a virtual system, which is today when we see the virtual systems, they are limited. They're limited. Why? Because they have less original data. Now, if you really want to see, let's suppose take an example of your manufacturing device or the car wheel alignment or the car gear or the car in the electronics, now the powertrain, right? Like, say now if we go to a manufacturing process and then you want to really see the powertrain or like your any part of your automotive part which has to be produced, and then the manufacturer has to give you a kind of assurance that like this has been tested to run for next 10 years or 15 years. Now, do we really how do they test, or like how do they say that like this will run for next 15 years, right? Like, say, so in a normal case, in 15 years, the assumption is if you run some say some x kilometers in next 15 years, the one way is to run those same kilometers at lab within a short time continuously, but still it will take more time, right? So now the more and the more data you want to analyze while doing this manufacturing process, so you introduce the sensors in the system and you get a lot of data, and you try to virtually produce the same system with those parameters basically, right? Like, say if it is a motor, you want to sense the speed of the motor, and then the temperature of the motor, the vibration of the motor. And then with this data, you are virtually creating a digital twin at the system, and then like you are analyzing the process of the wear and tear, and then the performance, and then the kind of physical or physical wear and tear, or like some physical changes which are appearing in the system by analyzing all this data, right? So now assume so now these kind of digital twins basically today are more depend on the sensors, but tomorrow when you see this high speed data is enabled, right? So now the 4 gigabytes and then 8 gigabytes per second, the data, when the data with the 5G is enabled, now merely it is possible to seamlessly integrate the remote system and build a digital twin at your local system, right? And then try to access it with a simple a seamless experience of the user. So that's why I stopped this screen. Why I stopped at this screen is basically, so now you can see. So earlier these things we have been still watching in some movies or something like that. So is something like it's going to come into our real world? More or less it's already started. It's, you have a transparent screens where you can produce all these kind of images. You have been getting a lot of data from multiple sources, but for that, the kind of data transmission need to be happen between one system to the other system is need to be very huge. That is what the limitation today we have with our 4G technology, the communication technologies. Yes, you might have some kind of like sitting in the lab where the wireless technology might not be an optional, but tomorrow you want to do it from anywhere, right? Like from a remote place. So at that time, so now this cellular, when you are bringing the data speed into your communication system, so these are the things which get evaluated at much faster rate, right? So that's I will leave you a couple of use cases. Like one is the logistics warehouse automation. You can see uh, because now, okay, so this is what we were talking about. So these are kind of oil wells where like all the lot of sensors are installed while pumping out the oil, and then like all these oil wells. So we did a project for GE to, it's around 10 years back, where we have upgraded their system. There was a FPGA system which are connected with the sensors, do the lot of processing, and then the data is pumped to the GE SCADA system, where they do all the analysis of the running system, because these all oil wells are running in remote, right? Okay, so similarly, these all are manufacturing, but for me the interesting was the healthcare one, where your robotics, it's possible. Yeah, here it is. Now what do you see the kind of digital twin in this case? Now can you just think of, here is the patient. The patient is not available to the actual surgeon who is sitting somewhere else. So now assume this patient is in India and the surgeon is in US, or like vice versa. The patient is in US and then like the surgeon is in India basically. Now the surgeon cannot access the patient, right? So now today he gives all the information or the knowledge he have, and then guide the systems, and then you go with this operation. Now assume there is a digital twin of this patient available near the doctor, and there is a digital twin available of the doctor in this operation theater. Today it looks funny. Try to recollect my statement. Is it possible to create the digital twin of this patient at the doctor who is sitting in his operation theater, and vice versa? Or is it possible to create the digital twin of the doctor among the available surgeons right now who are sitting and doing the operation in this operation theater, along with these physically available surgeons? You have created one more digital twin doctor who is doing operating physically to this patient. So today it might look like a funny idea, but with this growing technology of AI and with this growing technology of communication, so try to see that like whether it is possible or not. So this robotics today, they are taking actions as per the pre analytics basically, but like tomorrow we are feeding these robotics along with the real experience of a live person, and that is only possible when you have a huge communication system which can transfer a lot of data at a real time. So as I told, the technology from different, like you would be hearing 3G, 4G, 5G. So now when you are shifting from a user perspective, the two things is your latency, the speed, the data rate and the speed, and the latency. These are the two things which is going to play a major role. And here, this is one of the example which I would like to leave a question in your mind, that like, is it possible, and then like how long it would take. So please drop possible or not, yes or no. And then second thing is, how much time do you feel that like these kind of systems will be available in near future? When I say near future, what is that near future? Next 5 years, 10 years, 15 years, 20 years? Please leave your comments. Please leave your comments. The question is basically whether this operation, a surgical operation, can be developed with a digital twin of a patient at remote doctor, and a digital twin of a doctor at a local uh, operation theater, right? Okay. Now we were talking about the transportation, right? Like, so now in this transportation basically, you can see now in the electric vehicles basically. So you all ADAS systems comes. Now when you say ADAS system, now today when you have been doing any image processing, you have been taking some frames in one angle, but today like a 360 surrounding camera view, which might be available in couple of vehicles today, but it would be the most common use case for many places, even the medical use case which we have discussed about, right? Like, so now the surrounding view means the cameras would take the pictures from multiple angles, essentially 4 or 6 or 8 directions, stitch all the images and build a seamless surrounding view for you. right? So same like that, like when you are now in the latest vehicles, when you see these are the lot of things. So from a safety perspective, from the V2, V2V, V2X, V2I. So these are the different technologies which are coming into the vehicle domain, which needs a lot of reliable communication or a high speed communication, which the 5G is going to participate, right? And the standards have been defined, keeping these needs in place, basically. So when 5G standards has been defined, so these all use cases and the needs has been in place, right? So now you can see the kind of the driver drowsiness, or like the driver behavior. So all these things is going to be available in the systems, and then a lot of learnings happens, and the cars are becoming intelligent with these things, right? So same in avionics, basically. So so this is what we have discussed in the medical, right? Okay. So now when I was speaking on all these examples, basically, sorry, I skipped the agriculture one, but like I believe after seeing all these automations, you can easily correlate the kind of intelligence we bring in farming. Okay. So now whatever we have been talking, so it's not that like today it is not possible. Some level of these activities are already happening. So for example, recently we had our latest hardware, where which it can connect around 4 to 8 cameras in parallel. So this hardware can drive anywhere between 4 to 8 cameras in parallel, right? And then do all your edge processing on the same device. So this is our latest a hardware platform by TI. Similar platform we have by NXP IMX8M Plus. So where we are doing, so since COVID we have been participating with couple of semiconductor partners. So for whom we have helped to develop this AI accelerator chip design. So for us is basically, so we are working for some technology which is coming up to come for next 5 years or 10 years. And then for them, like we do develop the hardware and software, basically. And now when I see these use cases in the video clip what we have seen, it's not a movie stories now. So those are like going to be happening in real world. And then that it's not that like it will happen in another 2 3 centuries. So it will be rapidly growing. As you know, like the shift from the technology, the time taking to shift the technology is very less now, basically. Okay, so what I do is I will try to stop myself over here, and then like try to have some couple of questions, interactions. And then if you guys are having any specific topic you want me to expand, I believe I will leave uh, good time for that. Okay, so open. Yes, possible. Yes, possible. 10 to 15 years, 5G without latency. Yes, it's possible. Any questions? Maybe like the organizers can see if any questions I'm unable to see, and then maybe we can answer them. Yeah, Atul have raised a hand. Do we open a mic for them? How do we handle the questions? So I was expecting questions on the chat. I couldn't see much. Yep.
So we can open the mic for them, like they can allow to speak. So
Yeah, I think Shruti has raised a hand. So this hand raise is for that.
okay,
So
Shruti, please unmute yourself and you can speak.
like they just left the hand after the questions. So you can clear those hand raise, and then if people have some questions, they can live. By the time Sunita Joshi, a question: can you please tell me some topics of research in 5G? So now, if you are talking about the communication part of developing either 5G applications or developing the implementation of the 5G, so you have to be specific. So there are a lot of things. So as I told, so software defined radios, and then yesterday in deep. So last week, last session, Kaushalendra sir has brought you in deep architecture of 5G and how those are implemented. Okay, so I remember I worked in my first project in Wipro when we were working for Nokia. It was a 2G world at that time. So where I was part of a team where we used to handle Nokia NMS, network management system. So where we used to do all the software upgrades and maintenance for the BSC and MSC and BTS hardwares remotely. So that's what at least I worked. And then like I worked for Qualcomm for a couple of these modem chips and all. So there are Miss Sunita. So implementation of 5G, probably I think Kaushalendra sir will help you more. But there are a lot of stuffs, right? Like say again on the digital side, on the RF side. So like what your expertise is all about, or the application side, right? So now today I was more focusing on the application side. But like you can look into or like consult with other panel members who would be taking further more classes on the 5G part. Okay, so when you go for a specific implementation of 5G, you have to see that like what expertise do you carry, and then like what part of the research you can contribute, like say on the digital side or on the RF side. So one more very interesting part I would like to share you is what we have been working to enable, for example, enabling the energy meters, right? Like say, so now you can see something called 5G mesh. So how many of us even can dream that like you can have your own 5G network? It's possible. It's possible to build your own 5G network. Okay, and this is the technology behind. So there is a special purpose spectrum globally available. It's not really free. You have to register your purpose. So this is a special purpose spectrum. So for example, the government, the smart city applications, or the e-governance, or the things. So for them, like you need to put some register some application, and then you need to get some authorization so that like you can use them. So this 1.9 gigahertz, if you really see, you can I will share this link so that later on you can watch the video on that. So this is one of the latest project in 5G, where we are trying to help our partners to implement private 5G mesh network for IoT applications. So here the major focus was utility metering. So assume how many electricity meters, water meter, gas meters have to talk with each other, or like to send the data to the cloud. So that's one of the latest project which we have been supporting. right? So this is the advantage. So if you have heard about RISC-V, so maybe I would recommend you to also explore RISC-V and 5G design. So maybe you can look something on these topics, at least which I am aware. So we do a lot of custom processor designs, companies we support for their pre and post silicon validation. So these are a couple of things which at least I can guide you for the research, because I'm more a digital guy. So pardon me for the limited guidance. Okay, so how digital twinning can help agricultural applications, Kriti? So for say basically, so now same example of we took the remote surgery use case. Okay, so now tell me, how many agricultural experts are really participating on the field and trying to solve the problems of the farmers today? Can which can be approved? Can this be approved, improved with these latest technologies? As again, one these application which I have given, right, like 5G private mesh network, wherein which you can increase the number of sensors which can be deployed in the field. So these are a couple of use cases which will really bring a new level of definition in the smart agriculture, right? So if accuracy is compromised, then a lot of problems will be encountered. Please focus on key area that brings accuracy in 5G implementation. So this is more on the 5G technology part, Archana ji, basically. So maybe like I will leave it for other members, experts, basically. So yeah.
So probably this question would be taken in the next session.
Yeah, there are a lot of sessions where in deep 5G implementation and then 5G technologies were talked. And if you guys have missed Kaushalendra sir last week session, so please watch the recorded session, basically. So I'm more from a digital space. So we make these all embedded motherboards and then applications of IoT and all. So I thought, like, let me. That's why if you see my presentation was more on the applications rather going deep into the 5G. So from a 5G perspective, for me, only two takeouts, saying that like how the high data rate and low latency would help the applications to achieve, and what are the heights of applications, right? Like what are the deep level or next generation applications which would really change our lives. Today we are seeing maybe many of the events we see in movies, but those are going to become true now.
So I think all the questions are answered, right? Anyone else? Any questions? I think there's no one. So okay. Thank you so much, Vasudev sir, for answering those questions and for the great presentation. It was a pleasure to have you with us. I would also like to thank all the attendees. We hope you have learned and enjoyed this presentation. So here we will conclude the webinar and meet you all again in the next session on the 9th of December, same time at 11 a.m. with a new topic, Role of 5G for Other Emerging Technologies by Professor Ratnajeet Bhattacharya, IIT Guwahati. Thank you once again all, and you all have a great day ahead. Bye.
Thank you all.
Thank you, sir. Thank you, Vasu, sir. Thanks a lot. And thank you all. Have a nice day.